Now, that truth table definition of if-then might feel really weird to you. And that's because in English, we use that if-then language ambiguously. A lot of what's weird in logic is because natural language is ambiguous. And when we go to study logic, we want to nail it down and give it just one meaning. So how is if-then ambiguous? Well, if someone says to you, if it rains on Saturday, I'll stay home, you probably expect that if it doesn't rain on Saturday, they would go out. In fact, the normal thing would be for them to say, if it rains on Saturday, I'll stay home, in the middle of a conversation where they're telling you about all the fun things they're going to do on Saturday that involve going out. So in English, that if-then language sometimes doesn't mean what we mean by if-then in formal logic. Sometimes it indicates what's called a biconditional. Two statements P and Q are combined using a biconditional, written with this double arrow. So we see P double arrow Q, and read that as P if and only if Q. So we'll see P and Q with the symbol between them, and we'll say P if and only if Q. When we have that combination of statements, it's true when the statements have the same truth value. So either they're both true or they're both false. So if we have P and Q both true, the biconditional is true. If we have them both false, the biconditional is also true. But if one of them is true and the other one is false, then the biconditional is false. Both true, the biconditional is true. Both false, the biconditional is true. One of each, then the biconditional is false. Okay, so in logic, if we say if-then, we really mean if-then. We'll use that to refer to a conditional. When we want to say a biconditional, we will say if and only if. We'll discuss more about that only if part later on. And the reason that we have a way of saying a biconditional is that, well, sometimes when we're talking about math, we really have a biconditional. For example, this shape is a triangle. I'm looking at a shape right now. This shape is a triangle if and only if it has three sides. This is made of the statements, this shape is a triangle, we could call that P, and this shape has three sides, we could call that Q. We symbolize that as P if and only if Q. And you know that from geometry. If I show you a triangle, you automatically know it's going to have three sides. If I show you something with three sides, you automatically know it's a triangle. If I show you something that's not a triangle, you know it has some different number of sides than three. If I show you a shape with some different number of sides, I show you a shape with 7 sides, you automatically know that's not a triangle. So that's what that if and only if does. Either they're both true, so if you know one is true, you automatically know the other one is true, or they're both false. If you know one is false, you automatically know the other one is false.